Hello and welcome to my channel, The Curious Coder. In this video, we'll be diving into a complete guide on environment properties in Spring Boot. Everything you need to know about environment properties is packed right here in this video. Now this is going to be a long and detailed video, so before we start it, let me quickly walk you through what we'll be covering. First, we'll start with what are environment properties, why do we need them, the use of application.properties, configuration using external files, configuration using Spring profiles, @profile annotation, .properties versus .yaml, use of @value annotation, use of configuration properties annotation, and use of environment interface. Okay, so we'll be covering all these topics thoroughly. By the way, this complete video is actually a combination of 3 separate videos which I had already published. Okay. So if you are only interested in a particular subtopic and you already have a fair understanding of the rest, you can directly refer to those individual videos. But if you are new to the topic or want a strong fundamental understanding, I highly recommend watching the full video from start to finish, either here or maybe in those 3 parts, but watch them in a sequential order. Okay, that way you won't miss any critical connection between the concepts. Okay, so let's get started. Imagine this, you are building a Spring Boot application and it's working perfectly on your local machine. You are connecting it to a local database, everything runs smoothly and you think you are good to go. But the moment it's deployed to production, it tries to connect to that same local database and everything collapses. That's where environment properties come in. In real world projects, we work with multiple environments like dev, testing, production, and each of them often uses a different database. So you can't hardcode one DB URL and expect it to work everywhere. Okay, that's why environment specific configuration is required. So let's say there are 3 environments, a dev environment where you test things while you build them, a testing environment where QA team verifies your code, and finally a production environment where the live application runs. Now these environments have separate database with different URLs. For example, in dev, the URL might be something like this. In testing, it could be this. And in production, it might be this. So we'll have to define an environment property for DB URL. It will be a key value pair where key is something like spring.datasource.url and its value will keep on changing based on the environment. So I hope you guys got a gist of what environment properties are and why they are required. Now let's see on IntelliJ how they are actually configured in your application and how they are used. So there are 2 ways to configure environment properties. First is using application.properties file and the other way is using application.yml file. So right now I'll be using application.properties and I'll show you how we can configure the properties using that file. But later in the video, I'll also show you how we can do the same using the YAML file as well. Okay, so we have this properties file in this folder in resources. You can find it here. And basically, you can define the key value pairs that we just discussed over here. Okay, so I'll take a very basic example. I'll just define server.port and give the port as 8070. Okay, and let's say if I wouldn't have given this and if I just run it like this. Okay, so in this case, by default, my application starts on this port 8080. Okay, but if I define a property here as the server.port as 8070 and then I rerun it, great. Now the server started on port 8070. Okay, and I also have created a controller here where I have an API /message. So I can show you this. If I hit this API from 8080, see it's not able to send the request, but if I change it to 8070, great, this works. Okay, so this is how we can configure the properties in this file application.properties. It's very simple. You just have to add a key value pair and it works. Now I want to configure multiple values against this key. Okay, like we discussed earlier that we can basically what we want at the end is that we want to configure different values against one key. So how will I do that? So there are two ways to do that. First is using external files. Basically, I can create 3 different files for 3 different environments, and I can place them externally at some location, and my application will read from them. Okay, and the other way is that using Springboot files actually. So I'll teach you both of them in detail, and we'll see that how each of the approach works, because in your company you might be using either of them. Okay, so it's important to learn both of them from interview point of view as well. So let's look at the first approach. In this, we maintain a separate property file outside the application for every environment with configuration values specific to that environment. Okay, so in our example, we are setting the server.port. So let's say on dev, we want the app to run on port 8081. So the external property file will contain server.port as 8081. On test, it's 8082, so file will have 8082. And similarly for production, it will be 8083. So this is how we can configure 3 different values against the key server.port using 3 separate files. Now you might be wondering what happened to the application.properties file that we just saw on IntelliJ. Well, that file still exists inside the application jar. It doesn't disappear, it's still a part of your project. But here's the key point. When we provide an external property file, it overrides the internal one. So if a property is present in both the external and the internal file, then the external value takes priority and the internal one is ignored. Okay. But if a property is missing in the external file, then Spring Boot falls back to the value inside application.properties from within the jar. Okay, so let's take an example to understand this better. Suppose we define this property spring.application.name in our internal application.properties. It's a property that defines our application name basically. So I'm keeping its value as interview practice app in the internal file. Now let's say in the dev environment, we define this spring.application.name as dev app, and in test we write spring.application.name as test app. But in production, we don't define this property at all. Okay, so what happens in that case? On dev, Spring will use dev app. On test, it will use test app. But on production, since it's missing in the external file, it will use the internal one, interview practice app. Okay, so this fallback mechanism allows us to maintain default values inside the jar while still customizing them as needed for each environment using external configurations. Now, one more additional point here, that how do we actually tell Spring Boot to read this external property file instead of the one inside the jar? So it's very simple. When we run the application, we just pass the path of the external file using a command line argument, something like this. That's how we make our application behave differently for each environment without changing any code, because we passed this location as a command line argument and didn't actually change the code of the application. So I hope this first approach is clear to you. Now there is a drawback to this approach. Basically what we are doing is we are asking our application to read from a file which is placed at some location, right? But what if someone replaces the file at that location? Or maybe it's not replaced, but someone changes the data inside that file and the file gets corrupted, right? So, I mean, I know it's unlikely, but still, if it's a manual job, then a human error can take place and this can be done, right? So how can this be avoided? A better solution is that we keep all the 3 files inside our application instead of keeping them outside. Okay, and ask the application to read it from inside only, right? But now you can argue that the same mistake can be made inside as well. I mean, the file could be wrong inside as well, the data could be corrupted. But here's the thing, when we keep the files inside our application goes through a series of testing. Okay, so before it goes to production, a lot of testing takes place, dev testing, QA testing, it goes through demos. So it's highly unlikely that the mistake is not caught. Okay, so in that case, we will have better control over our files, and that's why it's better to keep it inside the application. And that's exactly what we'll do in the second approach. Okay, so let's see the second approach. So what I'll do is I'll create 3 different files. I'll go to resources and create a file, application-dev.properties, and here I can give the server.port as 8081. Okay, I'll continue with the same example. and I'll just copy this file and paste it here with the name as application.test. Here we can take it as 8082, and if I paste it again, now this time for prod, application-prod.properties, and the port is 8083. Fine, so I have taken the same example, but this time I have created all the three files inside the application, right? And we also have this file, the application.properties, which is the default one, and here we have the port as 8070. Fine, so I'll rerun my project. Okay, so this time the server started on the port 8070. Now why? Why is that? Because you see, we have created three separate files, but Spring Boot doesn't know yet that from where it has to read. Right, so Spring Boot only knows that we have a default file, application.properties. So it comes to this file and it sees that, okay, we have this server.port as 8070, and hence the application runs on 8070. Okay, so if I have to activate these files, then I will have to tell Spring Boot that it has to explicitly go to one of these files and read from it, right? So how can I do that? So basically we use a concept of Spring profiles here. Okay, if we have to activate any of these files, then I will have to create a profile for that particular file. Okay, so I'll show you spring.profiles.active, let's say dev. Fine, so basically since Spring Boot knows this file application.properties, so here only I'll be giving this configuration spring.profiles.active, and I'll activate this particular profile dev. Fine, so the naming convention is that this should be same as whatever I have written here after the hyphen. Okay, and similarly I can write test and prod over here. So whichever profile I want to be activated, I'll write it here. And now if I rerun my project, great, this time it runs on port 8081, and you can also see a logger saying that the following one profile is active, dev. Okay, so what happened is that Spring Boot again read from this file only, application.properties. It saw this as well, server.port as 8070, but then it saw that one profile is active. Okay, and which one? The dev one. So then it scanned the project again and it saw that, okay, we have this file here, application-dev.properties, and here we have the same key, server.port, but its value is 8081. Okay, so it overrides the default application.properties the same way that was done when we were talking about that external property file. Okay, so it's the same logic. So if I change it to test, in that case the test file will override the default application.properties, and this time you can see that it will run on port 8082. Okay, and the profile which is active is test. And if similarly if I change it to prod, so by the same logic, yeah, so okay, so by the same logic it runs on 8083 and the activated profile is prod. Fine, now what is the purpose of this statement then, this server.port as 8070? So let's say if I remove it from here, from prod, and the active profile is prod, right? Now if I rerun it, great, it runs on the port 8070. Why? Because again it uses this file as a fallback mechanism. So since in application.prod we don't have that property server.port, that's why it then falls back to this class basically this file application.properties, which is the default one, and it sees that key over here which says server.port as 8070. Okay, so this is how we can configure various profiles for our project. Now we can also activate multiple profiles together at the same time. Okay, so let me show you. What I'll do is I'll just add it like this, prod, test, dev. So this means that all the three profiles are active at the same time. Okay, and their priority order is from left to right. So prod will have the least priority and dev will have the most priority. Okay, so in case of conflict, dev will be considered first and prod will be considered last. Okay, so let me just run this. Okay, first I'll add server.port as 8083 again. So in dev it's 8081, in prod it's 8083, and in test it's 8082. And in our default file we have it as 8070, and all the three profiles are active. Okay, so I'll just run it. Cool. So it started on port 8081. Why? Because the dev profile has the most priority. Okay, and you can see in the logger that the following three profiles are active. Okay, so now the logger is also saying that all the three profiles are active. Okay, so let's do one thing. I'll just remove this server.port from the dev file, and now let's see what happens. Great. So it started on port 8082 and still all the three profiles are active. Okay, so why did it start on 8082? Because after dev, the second priority is of test, and in test, we have it as 8082. Okay, so this is how it works. Now, had it been only dev profile, let's say I would have activated only the dev profile, and now if I run it, great. Now it starts on 8070. Okay, why? Because in this case, the test and the prod are not at all active. Okay, they are not active. So after dev, it will not consider any of these profiles. It will directly go to the fallback application.properties, which is this one, the default one. Okay, so this is the difference. Like if we activate these profiles, we still consider them, and only in case of a conflict, we consider the one which has the highest priority. But let's say there is no conflict, then the lowest priority also gets considered. But if those profiles are never active, then you can assume that these two files have no use here. Okay, we can add as many properties as we want, but they will never be considered because their profiles are never active. Okay, so this is how it works. Now let's say, let's complete this example. It was like this: prod, test, dev, and in dev I don't have the property. Let's say I don't have the property in test as well. Okay, so now if I rerun it, great. So this time it starts on port 8083, which is basically this one, the application-prod.properties one. Okay, because next in line was this prod one. And you can guess this, that if I remove it from here as well, great. So then it starts on port 8070. Okay, so it will be coming to the fallback application.properties, because now none of them have configured server.port in their property file. Okay, cool. Now there is one problem in this approach. What we are doing is we are defining a priority order in this application.properties file, but this application.properties file will always be the same for all the environments. Okay, because this file is part of the application, and hence it will be part of the application jar that will be deployed on all the environments. And we have already seen that we deploy the same jar on all environments. So we cannot have a different application.properties file for different environments, and hence we cannot have a different priority order for different environment. Getting my point? So let's say in this example, dev has the most priority. So when we deploy our application to dev, it will have the most priority. But when we deploy it to test, then also dev profile will have the most priority, right? But that is wrong. Okay, so that should not happen. What I want is that in dev environment, dev profile should be given the most priority. In test profile should have the most priority. And similarly in production, prod profile should have the most priority, right? So somehow I want this property to be set dynamically instead of hard coding it here in application.properties file, right? So how can that be done? Basically, the answer is very simple. We will have to use command line arguments for that. Okay, so instead of hard coding it here, we'll have to use a command line argument while running our application. So when we will deploy on dev, in the command line argument, we'll give this property and activate the dev profile, or maybe give it the highest priority. Similarly, when we deploy on test, we'll give test the highest priority, and when we'll deploy on production, we'll give the production the highest priority while running the command. Okay, and I can show you the same here in IntelliJ as well. Here we have one option. You go here, edit configuration, and in modify options we have add VM options. Okay, so here we can write it like this: -d spring dot profiles dot active is equal to, let's say, dev. Okay, so it's like command line argument only, and I'll apply my changes. Okay, I think it's small d, yeah, dev, and I'll apply my changes and okay. And now if I rerun it, okay, so first let me check, do we have any? Okay, so we don't have any port. First let me add a port here, server.port as 8081. Okay, and let's say do I have this? Yeah, so it's already dev, and if I run it, great, so it started on port 8081, and you can see that the profile which is active is dev. Now I will not change anything in the code, I'll just change my configuration to test, and I'll run it again. Great, so actually it's 8070 because I think in test we don't have anything. Yeah, so in test we don't have anything, so it went back to the fallback. But again, if I will add here server.port as 8082 and I'll rerun it again, cool, so it started on port 8082, and you can see the profile which is active is test. Fine, so this is how we can give our Spring profile configuration dynamically, and this is exactly what we do while we deploy the application to our environments. Okay, so I hope it's clear. Now I'll tell you about one very important and interesting annotation, @profile annotation. Okay, so what it does is, let's say I want to create a class, let's say employee, and I want to create a bean of this class. Okay, but I want to create the bean only on the dev environment and not on prod and test environment. Okay, so how can that be done? For that we use @profile annotation. Okay, so I'll just add @profile and I'll add dev over here. Okay, and let's create a constructor to see. System.out.println, this is employee bean. Okay, so I have created an employee class and I have configured @profile as dev. So the bean will be created only when the profile is dev. Okay, so right now in the configuration, the profile is test. So let's change it to dev, apply, okay, and I'll rerun my project. Great. So you can see this print statement that this bean has been initialized. And now if I change it to, let's say, test, okay, great. So now it's not created. Okay, we can check this. Okay, so it's not created. Fine, so this is how, if we want to create a particular bean based on some environment, so this can be done using @profile annotation, and we can actually configure it for multiple environments as well, like this. Let's say it was configured for dev and test, and now if I rerun it, okay, so now the employee bean is created because it was configured for both dev as well as test, and our profile, active profile, was test. Now let's say if it's prod and I apply again, Okay, now it's not created. Fine. So this is how we can work with @profile annotation. Now so far, we have seen how to configure environment properties using application.properties file and how to work with multiple Spring profiles in your project, right? But when we already have a perfectly working application.properties file, then why do we even need an application.yml file? Correct. So there are two good reasons, and one by one we'll look into both of them. The first reason we might prefer YAML is because of its support for hierarchical structures. Okay, so let's continue with our example of server.port only. In application.properties, we will write it like this. But in application.yaml, the same thing would look like this. Okay, it's indentation based. Now, how is this helpful? Let me show you a bit more complex example and we'll find out. Suppose we have to add all the database related properties. It will look like these in a properties file. And if we write the same thing in YAML, now just look at how much cleaner and organized this is. Right? In a properties file, all the keys are flat and there's no visual grouping. In a large project, you might have these lines scattered in different places far apart from each other. But in YAML, all the related properties are grouped hierarchically under one block, so it becomes really easy to find, read and manage all the related configuration settings. Right? Let's take one more example to build on this hierarchy. This time we'll take spring.jpa properties, which are commonly used alongside spring.datasource. Okay, so here's how the config might look in a properties file. If you look at it, even though these properties are related, they are still just a bunch of key value pairs, all flat. So you might write spring.datasource at the top of the file and spring.jpa far below, and it becomes difficult to see that they actually belong to the same database configuration context. Now let's look at the YAML version. Much better, right? Everything under Spring is structured clearly. We have data source and JPA, two separate blocks, but both are part of Spring. So visually, it's very easy to spot how your Spring Boot app is configured. This hierarchical structure is what makes YAML so much better when you have a lot of config. Now, you can see that we have created 4 different files here for 3 different environments and one default application.property file, right? But using application.yaml, I could do all of this in just one file. Okay, and that's the reason we prefer application.yaml over application.properties. Okay, so let me show you. I'll just delete all these files and I'll create a new file, application.yaml. Cool. So by design, application.yaml supports multi-document files. Okay, so that basically solves our problem. We can create different document for different Spring profiles and we can put all of them inside this application.yaml file. Okay, so let me show you how. We just have to add these 3 dashes and it just creates a new document. Okay, so let's say this first one is the default document. So I'll just configure server.port as 8070. Okay, then I have added this dash, these 3 dashes, which have created a new document. So now I'll use this document for the dev profile. Okay, so I have to add a property for that. I'll just say spring config activate on profile. Okay, and I'll write dev here. Fine. So this means that we have designated this document for the dev profile. Okay, and I can define a different server.port here now. Server port as 8081. Now similarly, I'll create another document. This one will be for test. So I'll just copy paste now. This is for test 8082. And here we can configure prod. Okay. We can define which particular profile is active using the command line arguments. So that I've done here like this. Okay, so you can see -d spring.profiles.active is equal to prod. So right now prod profile is active. Okay, so let's test it. in prod we have the port as 8083. Great. So you can see that Tomcat started on port 8083, and also that the bean of employee class is not created. Okay, this constructor is not called. This is employee bean. Now if I'll just change it to test, I'll rerun it. Great. Now it starts on port 8082, and you can see that employee bean is also created. Fine. Similarly, I can test for dev as well. I'll change it to dev. So again the bean is created and it started on port 8081. Fine. So this is how we can configure multiple Spring profiles using application.yaml in just one file. Okay, so this is the benefit of using it, and as we discussed, the first reason that the indentation does make it look good. Okay, now if I remove server.port from here, let's say I've commented it out and I rerun it. So this time the port started on 8070. Okay, so server started on port 8070 because we didn't have any server.port in our dev profile, and then it went back to the fallback default application.property, basically default application.file. Okay, so this first document. Fine. Now let's say I want to configure database properties as well. So as you know, the database properties are, let's say I'll take one example. Let's say we want to configure spring.datasource.url. Okay, so how will I configure that? Let me try it. Spring data source and URL. Okay, but it is giving me an error saying that key spring is duplicated. Okay, so yeah, because I already have written spring over here, so I cannot write spring again here in the same document. Okay, the key will be duplicated. So this basically restricts me that I have to write data source here. Okay, I have to give it something like this, data source URL. Okay, and that's why I cannot basically in YAML file I won't be able to write any property which has the prefix spring. I will have to write it here only. Okay, I won't be able to write it below, or like I cannot change its structure. Okay, so it will be in the same block which is present over here, and that's why it's easy to read, easy to maintain. Okay, so I just wanted to show you this. Yeah, so I hope it's clear why we prefer application.yaml over application.properties. Now, so far we have only talked about Spring Boot's built-in environment properties like server.port or spring.datasource.url, but Spring Boot also allows us to create our own custom properties, and we can access them in our application using different ways. So let me show you how we can actually configure a custom environment property in our application. I'll take a very simple example. Let's say we have a feature that enables two-factor authentication in our application. Okay, and I want that feature to be enabled only for prod environment and not for dev or test environment, right? So how will I do that? Okay, so it's very simple. What I'll do is I'll create a key of my own. Let's say feature is 2fa. Okay, so feature 2fa and enabled. So feature.2fa.enabled, and in dev keep it as false. Similarly in test again I'll keep it as false, and in prod, okay, not here, yeah, in prod I'll keep it as true. Okay, so I created a key of my own and I gave it different values in different environments, right? Now I want to clarify one thing. I'm not actually showing you how we can perform two-factor authentication. I'm just saying that you can assume that there is a two-factor authentication feature in my application. It's just an example, and I'm just showing you that how we can enable or disable it based on different environments. Okay, that I want to show you. Cool. So this is how we have configured a key and a property of our own, and now I want to use this property in my application. Okay, so how can that be done? So there are three different ways. First is using @value annotation. Second is using @configuration_properties annotation. And third is using a reference of environment class. Okay, so one by one I'll show you all the ways. What I'll do is I'll just create an API. Public boolean is 2FA enabled, and let's say I map it to some URL /2FA. Okay, so I created an API which tells me whether 2FA is enabled in the application or not. Okay, and it will return a boolean value. So since it returns a boolean value, can I just hardcode true or false here? No, I can't, because I want it to be true for prod environment, but I want it to be false for dev and test environment, right? And if I hardcode it, then the API structure will be same for all the environments, and I won't be able to achieve this, right? So what I want is, I want to access that application property that I just configured in this class, right? If somehow I can access that, then my problem will be solved. Okay, so it's very simple. I'll just declare a boolean variable, let's say is 2FA, and I'll return this variable, return is 2FA, and I'll inject the value @value of that property. Okay, I'll inject the value of that property in this variable. Okay, so I'll add a placeholder here like this, and here we'll have to give the property name. So property is feature.2fa.enabled, right? So we'll just add feature.2fa.enabled. Okay, so that's it. So I have created a boolean variable and I have injected the value against this property inside this variable, and I'm returning this variable in this API. Fine. Now, right now, my profile is, the active profile is dev. Okay, so active profile is dev, and for dev it should return false, right? So let's test it. Okay, so Tomcat started on 8081, active profile is dev, and I'll just hit this API. Great. So you can see that it returned false. Now if I'll change it to prod, let's say prod, and rerun my project. Okay, so this time it started on port 8083 because I have also configured different ports for different environment. So for prod it's 8083, and I'll just hit on 83/2FA. Great. So this time this returns true. Okay, so this is how we can configure our own application.property, our own application property, and we can use it in our application using @value annotation. Okay, so I hope it's clear. Now let's say I want to configure another environment property. Okay, I want to configure how I will be sending the 2FA code to user. Okay, like via SMS or via email. So let's say for dev and test, I want to send it via SMS, but on prod, I want to send it via email. Fine. So how can I configure that? Again, I'll just create another key. Let's say feature.2fa.provider, and I'll just write SMS. Okay. Now since this property is also related to 2FA, that's why I've kept it here in this hierarchy. Fine. So similarly here in test, I will keep it as, again I will keep it as SMS, and maybe on prod I'll keep it as email. Fine. So this is how I have configured another environment property related to 2FA feature in my application.yml. Okay. So what I'll do is I'll take another example. I'll just create another controller, controller2. Okay, @rest controller annotation. Yeah. So I'll just create an API public void send to FA code. Send to FA code. Okay. So the purpose of this API is to actually send the code to the user. Fine. Now again, I want to remind you that I'm not teaching you how we actually perform two-factor authentication. I'm just showing you how we can use our environment properties in our APIs. Okay, in my application, I'm just giving you an example. Okay, so focus on that part. Now let me map it with some URL. Let's say /send to FA. Okay, so now logically, what should be there in this API? Like when you are hitting an API to send the two-factor authentication, the first thing that we'll check is whether or not 2FA is enabled. Okay, so like first we need to check that whether is 2FA enabled, like something like this, and if it's enabled, then we'll just run a piece of code, and if it's not, then maybe we can throw some error. Okay, throw some error, right? So again, I'll have to take a variable private boolean is 2FA enabled. Okay, like this, and I'll inject the value from application.yml. Okay, so I'll just copy this one only the same way, like this. Fine, cool. So now when it checks that okay 2FA is enabled, now let's say for email flow we have one particular piece of code, and for SMS flow we have a different piece of code. Okay, so now I also have to check whether or not SMS flow is enabled or email flow is enabled, right? So for that I'll take another variable, and it will be string, and it will be provider. Okay, let's say provider, something like this, and I'll inject a value again, @value dollar. Okay, and this time I'll put the other key, okay, this one, provider, like this, and we'll check okay if provider dot equals, let's say SMS, then we'll have send via SMS. Okay, we'll have this piece of code, and if it is, let's say else if it's provider dot equals email, then we'll have a different code. Okay, so something like send via email. Okay, we'll have the code to send the 2FA code via email. Okay, so this is what my API should look like, right? Now you can see that this property is 2FA enabled has been injected twice in this application. Okay, we have used it here as well as here, right? And in this controller we have also used another property, this provider. Okay, so let's say there are many properties and they are again reused in many different APIs in many different controllers, so that will lead to a bit of repetitiveness in the code. Okay, so is there a better way to do this? So actually yes, there is a better way. In situations like these, we can actually use something called configuration properties, and that is the second way to access environment properties. Okay, so I'll show you. It's very simple. I'll just create a class, let's say two-factor authentication properties. Okay, something like this, and I'll just add an annotation @configuration_properties. And since I'm defining all the configuration properties for 2FA here, so I'll just give a prefix as 2FA dot feature. Okay, so all the properties that are starting, okay, it's feature dot 2FA, my bad, it's feature dot 2FA. Fine. So all the properties that are starting with this prefix can be configured, can be injected in this class, in this two-factor authentication properties. And I will just declare variables for these properties. So one will be private boolean enabled, okay, and the other one will be private string provider. Fine, that's it. This is how I can inject my properties in one class, and then I can use this class throughout my application. I just have to create a bean of this class. So I'll say @component, and now I can auto-wire this class anywhere in my project, and I can directly use these variables. Okay, so the injection process takes place only once, and we have all the logic of two-factor authentication properties in one class only. Okay, so this is how my code is very clean. Okay, so this is a better approach than @value. Fine. Now what I'll do is I'll also add the getters and setters for this. Okay, so I have not added Lombok. Fine, so I'll just create it like this. Generate getter and setter. Cool. So now in my controller, instead of injecting it using @value, I'll just create two variable, auto-wire this class private two-factor authentication like this. I'll auto-wire it, and we can directly use the variable. Okay, two-factor authentication dot is enabled. Okay, and similarly here I can dot provider dot get provider dot equals SMS, and here it's properties dot get provider dot equals email. Okay, so this is how I can access this anywhere in my project and in my first controller as well. I'll not use @value. I will just auto-wire this class private two-factor authentication like this, @auto-wired, and instead of returning is to FA, I will return dot is enabled. Okay, so it's very simple, and let's test it as well. I'll just hit this API only, this /2FA. Okay, so /2FA, and I think it's up on 8083. Yeah, so let me run my code. Great. So Tomcat started on 8083, and I'll just hit this API to show you. 8083. Good. So I'm getting true as the response. So in this API, 2FA is enabled because right now the profile which is active is prod, and on prod we have already enabled the two-factor authentication, right? And if I also hit this API, let's say /send, okay, I have not written any code here, but it will work fine. So this is how we can configure our application properties using application.yml, and we can access them using @value as well as configuration properties. Now so far we have seen two ways to access environment properties. First is using @value annotation, and second is using configuration properties. Okay, now I'm going to show you the third way, that is by using environment class reference. Okay, so what is environment class? It is a class that is provided to us by Spring Boot only, so we can directly use it in our application. Okay, so I'll just show you private environment, okay, like this, and I'll auto-wire it @auto-wire. Okay, so this is an interface which extends this interface property resolver, which has some methods, okay, like this one, get property. So we'll be using this method only. What it does is I can just write environment.getProperty, and I can give the property name here in the first argument. Okay, so property is feature.2fa.enabled, like this. Now since it returns a string value by default, but we have another overloaded method which also takes another argument, which is the class type basically. Okay, so I'll use that because I want a boolean value, and I'll just write boolean.class. Okay, like this, and we'll store this in a variable is 2fa is equal to environment.getProperty. Fine. Now instead of checking it like this, I can just use this variable if is 2fa, then we should run this code, otherwise we should throw some error. Okay, similarly for provider, I can create another variable environment.getProperty feature.2fa.provider. okay, and since it's already a string value, so I won't add a second argument here, and I'll just put it in a string variable, let's say provider. Fine. Now I can replace it here if provider dot equals sms and if provider dot equals email. Okay, and I can also write some print statements. We'll just run this API dot println sms flow triggered. Okay, and here dot out dot println email flow triggered. Fine. So this is how you can use environment reference to access the properties. It's not exactly a better way. I would say that configuration properties is still the best way because we have all the properties consolidated in one class, and we know like where is the logic of accessing those properties. So it's more clean and it's more easy to debug if we face any problem. Also, maybe if we change a property, okay, if we change any key, then we can simply change in one class, right? It would be easy. But if we are using environment reference, then we would have to change wherever we have used the environment reference, right? Or maybe if we are using @value annotation, then also we would have to change it at every place where we are using the value annotation. Okay, so that's why configuration property is the best way. But okay, this is also one way, and I'll show you by running this API. Fine, so let me start the project. Okay, so it started on port 8083 and the active profile is prod. Okay, so on prod we have configured it as email. Okay, and the 2fa flow is also enabled. Fine, so I'll just open Postman. Cool. So we have our application started on 8083 and we have this API /send to fa. Fine, so I'll just change it to send to fa and hit this API. Okay, so you'll see that email flow is triggered. Okay, and if I change my profile to, let's say, dev, okay, and here we actually for dev the 2fa is not enabled, so it will directly come here. So what I'll do is I'll also enable the 2fa flow for dev. Okay, so let's make it as true now and we'll rerun. Great. So project started on port 881 and the active profile is dev, and I'll just change it to 8081 and hit send to fa. Cool. So this time the statement that will be printed is SMS flow triggered. Okay, because in this controller 2FA was true, and then for dev profile we have configured the provider as SMS, so that's why the SMS flow has been triggered. Okay, so this is how we can access these environment properties using multiple ways. I hope it's clear, and I hope you liked the video.
If you found the video helpful, please like, subscribe and hit the bell icon. Also, don't forget to catch today's tip of the day.